Hi guys, Mrs. Delisin here. Welcome to another lesson of Algebra 2. Today's lesson is square root to constant. What does that mean? Learning objectives, I will learn how to solve simple square root equations. I will learn how to check square root equations for extraneous solution. That is something that you have here in Algebra 1. And hopefully when you go through everything, you'll remember what that is. Okay? There is one important lesson in this, or let me just read the whole thing. Okay, the basic of this entire unit is to get the square root part by itself on one side of the equation, then square root both sides of the equation. This procedure eliminates the square root from there. We can use previously learned techniques, typically those involving linear or quadratic equation. There is one important thing that you have to remember for this lesson though. Whenever you square both sides of the equation, you technically get a new but related equation. And sometimes when you do this, you obtain a solution that may work for the new equation but does not work for the original equation. Such answers are called extraneous solutions. So an important procedure to remember that when you finish solving for x, double check your solution by plugging them back into both sides of the original equation. Right? If both sides result in the same real number, then the solution should be included in the solution set. If two sides result in different real numbers, then the solution should not be included in your solution set. If one side results in complex number, then this should not be included in your solution set. How does that work? Okay, let's have our first example. Remember, our first goal is to leave x by itself, right? Solve for the value of x. So we have here 4 times the square root of x minus 5 equals 24. Of course, your goal is to leave this alone. So you're going to get rid of the 4. You have 4, let's write that first, equals 24. So your goal is to get rid of the 4. So you're going to have to divide that on both sides. You're going to end up with x square root of x minus 5 equals 6. And of course, we remember from the previous lesson that if you have to eliminate a square, you square it both sides, right? But then if you have to eliminate a square root, then you square both sides. So what we're going to do here is we're going to square this and square that. So we're going to end up with just x minus 5. And then this one is now going to be 36. And then you're going to move on to adding 5 on both sides. So you're going to end up with x equals 41. And remember, you are not done. You need to make sure that the 41 works on this side and on that side, right? So if we plug in, technically, what I meant was, if I plug in 41, would the number be equal to 24? Right? So usually what I do is I name it left. Okay, there's no space. I name it left and right. On the right side of the equation, I have a 24. On the left side, I still don't know. So if I plug 41 in there, minus 5, the issue is, will I get 24? Right? So we have 41 minus 5 is 36. And then, of course, PEMDAS, you have to solve the one in the square root first. So we have square root of 36. Is it not 6? Oops, what's that? Square root of 36 is 6. And so this is 4 times 6 is 24. So you have a 24 on the left, 24 on the right. Because when I plug in 41, it works. My final answer is 41. Miss, do you mean to say that if these did not equal to each other, this is not a solution? Yes. So you'll get this one here, but you would say no real solution because the 41 did not work and no other number would work. Okay, moving on. Here we have the square root of x plus 9 minus 3 equals negative 1. Of course, let's add a 3 on both sides. We have a square root of x plus 9 equals 2, right? We have square both sides. We are left with x plus 9 equals to 4. And then we have x equals 2. Of course, you subtract the 9, so you have 4 minus 9, which is negative 5. So x is equal to negative 5. So you're going to be plugging that in, my left and my right. On my right side, I have a negative 1. My goal is, if I plugged in negative 5, will I get negative 1? So let's do that. We have negative 5 plus 9 minus 3. Negative 5 plus 9 is positive 4 minus 3. And you have to solve whatever is in the square root first. Square root of 4 is going to be 2 minus 3 is negative 1. So you have a negative 1 on the left, you have a negative 1 on the right. Therefore, negative 1 is equal to each other. Therefore, this is negative 5. Right? Because this end up to a number that is the same, this x is your answer. Because these end up, this is technically you're checking your solution. Because it works, whatever the x value is your final answer. Okay, let's try this one. This looks like a lot, right? So we have, what do we do first? Do we subtract 14 first or do we divide? Of course, we're doing it, right? A backward of, what am I doing? So we have, copy that first. You have 3x minus 2 plus 14 equals 2. Of course, subtract 14 on both sides of the equation. Then you have 2 minus 14. So you go 3 times x, square root of x minus 2 equals negative 12. Remember the negative. Divide by 3 on both sides. Square root of x minus 2 equals negative 4. And then you are going to get, in reality, you could stop in here. Why? Because there is no such thing that you could plug in into the x that will end up with the negative 4. But just for the sake of solving this, let us continue. So we have squared, and then we have x minus 2 equals 16. And then we'll add 2, so x is equal to 18. So what we're going to do is plug in the 18 and see if it will be equal to 2. So, don't have space. We have here my right, left and right. My right is 2. So I'm going to try to copy. Let's copy the equation first. And let's plug in 18 and see what's going to happen. So you have 18 minus 2 plus 14. I hope you guys are following. We have 3. 18 minus 2 is going to be 16. Then plus 14. So I'm going to solve what is the square root of 16 first. So that's a 4 plus 14. And then I'm going to have a 12 plus 14. And 12 plus 14 is 26. So you have 26 on the left, but you do have 2 on the right. So they don't match. That means that on here, on our solution, we put no real solution. because 18 did not work. So there's no real solution to this problem. Okay, I will repeat. If they ended up equal to each other, whatever the x value is the final answer. But in here, because when I plug into checked, the left side and the right side didn't equal to each other, so we will put no real solution. Let's see if this one would work for the other side. We have 5, 2x plus 1 minus 11 equals 19. Add 11 on both sides. We are going to get 19 plus 11, so that's going to be 30. And then divide by 5 on both sides. That's, of course, is 6. And you are left with 2x plus 1. Remember that in order for us to eliminate the square root, we will square both sides of the equation. You're left with 2x plus 1, and you're left with 36 on the other side. So let's continue eliminating everything except the x. We're going to leave x alone. So you're going to subtract 1. So that's 2x equals 35. You divide by 2, and you're going to end up with 35 over 2. Now, let us check if 35 over 2 would, let me put that in, it's too big. Okay, let me put, where do I put that one? Let us insert a page. There you go. So we have 5. I have left and right. Okay. So on the left, on the right, I already know I have a 19. So our goal is when we plug in 35 over 2, would that be equal to 19? Let's do that. So we have 2 times 35 over 2 plus 1 minus 11. You have 5. Again, the 2 gets canceled, so that's 35 plus 1 minus 11. I'm doing it really, really, really detailed. We have 36 minus 11. And then the square root of 36 is 6, isn't it? So we have that minus 11. So we have 5 times 6 is 30. Minus 11 is going to be 19. So we have 19 on the left. We have 19 on the right. So they both equal to each other. Therefore, our final answer here is 35 over 2. Okay? What do you guys think? That's not bad, right? I hope that it's not that bad. And again, this part that I'm doing over here, it's just that I am checking, right? So when I plug in left, right, that is just you checking. This one is checking the problem or checking if it works. And because if it doesn't, then you would say no real solution. All right? I'm hoping that this helped you with your square root to constant homework. Thank you guys, and I will see you guys on the next video. Bye.